All right, it's recording. Here we go. Exercise 8I. Let's have a look at this problem. Let's say I gave you a spinner. And we spun this wheel. Now, imagine there was a tab. This wheel will spin, and wherever the tab lands on, that's the number that is chosen, right? So, if I asked you, this is what you did last week, a G, if I said, what is the probability of getting a 2 when you spin the wheel? Okay, so this is my notation. Probability, so PR, because there's mathematicians, we're too lazy to write the actual sentence. We say PR bracket. Now inside is what I want. I want to get a 2. So I just say PR 2, which means what's the chances of getting a 2 in this context means spinning the wheel. What would the chances be? Hands up if you know. What's the chances if I spun this wheel right now? What's the chance of getting a 2? Sully. 1 in 3. Why is it 1 in 3? Well, you've got 1, 2, 3 options in total, but there's only 1, 2 that you're interested in. So hence you'd say it's 1 out of 3 possible chance. Now this one is relatively easy. Intuitive, most students will get. Don't really need me to explain much further. But how I then make it a bit more difficult is I might ask the second question now. I might say, what if we spin the wheel 3 times? Okay, and then I ask you, what is the probability of getting all 2s? Meaning, if you spun it the first time, what's the chance of you getting a 2? Then get a 2 on the second, and then get a 2 on the third go. Now, as I ask you that, what's the probability of getting a 2 on the first, 2 on the second, and 2 on the third? Some of you already know the answer intuitively, okay, because this one was intuitive. Some of you already know the answer intuitively here, but then there's a middle group who may just need a bit more time and they can figure this one out, right? And then there's a smaller portion of the group where even if I gave them that time, students would give up. It's not that they can't figure it out intuitively. They can, but you'll likely give up just because there's so many numbers happening in your head and you give up. What we're trying to do is we're trying to teach you a tool to bring that middle group and that bottom group away to feel confident that you can answer that question. Now, when I look at that question, I think of it intuitively like this. You told me, Sully told me that chance of getting a 2 was 1/3. So it's about 33% chance. So you got 33% chance, or 1/3, to get the first one. Then if you spun the second time, you got 33% chance of the 33% chance. So a third of your third. Does that make sense? So a third of a third chance to get 2 2s. And then I'm thinking about that by the time you get to the third one, intuitively, I'm understanding it as you're getting a third of a third of a third. Because you're really saying to get a 2, it's a third. But to get this 2, you need another third. And to get that 2, you need another third. So in total, mathematically, what does the of mean again? Add, subtract, multiply, divide. Which one is it? Multiply. So in my mind, I already had a third times a third times a third. And we already know the answer is 1 times 1 times 1 is 1. 3 times 3 times 3, 27. But that's me intuitively. Now, I don't know how many of you before already had the answers 1 out of 27 in your head. Some of you did, but that's a smaller portion. There's a middle group who might have arrived at the answer a bit of logic. So intuitively, some of you might have been doing this in your head. You might have said, well, you could get a 1 on the first go, 1 on the second go, 1 on the third go. You might say, I could get 1 on the first go, 1 on the second go, and then 2 on the third go. I could have that 1, 1, 3, or maybe 1, 2, 1, 1, 2, 2. Now, if you follow this pattern, you probably can figure out it'll be 1 out of 27 because you would have listed all 27 options intuitively. You would have sat there. And if you organized your thinking, it will likely be that you won't miss a solution. But if you're not organized in your thinking, it'll be all messy and all that, and then you won't be able to get the correct answer. So that's the middle group. Then there's a bottom group who, as you're listing this out, and you're like, oh man, that's too many numbers, and you gave up. Okay, so there's a bottom group there that you would have given up because there's too many numbers, right? This is why we teach you a visual aid to think about it logically, to bring that bottom group and the middle group a tool to solve that problem. So either you had it intuitively, or you had it intuitively, but it will take you a bit more time. Or now I'm teaching you a technique, which is called tree diagrams. Now let's visualize this. See, on the first go, when you spin the wheel, how many options do you have again? How many options can you get? 3. So you get 1, 2, 3. This is the first spin. So the first spin, you can get 1, 2, or 3. We don't know which one. It's one of these. Then when you do your second spin, the logic is if you had 1 on the first go, then your second go could still be 1, 2, 3. So you get another 1, 2, or 3. Now what's interesting is if you count the number of options so far, for the first go, you told me 3 options. But if you look at the second go, there's a pattern. There is a pattern that allows you to figure out this. Let's have a look. For this one, if you got 1 on the first go, you could get again 1, 1, 1, 2, or 3 on the second go there. So 1, 3. If you followed this one, you could have got 2 on the first go, then 1 on the second, 2 on the second, or 3 on the second. What's the total number of options? If I flipped it twice, spun the wheel twice, how many options can you get? How many options do you think in total? Yeah, there's 9. There's 9 totals if I spun it twice, and if it's looking for 3 2s, it's 1 out of 9. So how do we go from 3 to 9? So I want you to see the pattern here. For every option you had, there's another 3. So it's 3 groups of 3. Is that what you were going to say?
It's like powers in one. It's 3 to the power of 3 because 3 times 3 is 9 and 9 times 3 is 27.
It's very good. Yep. Yep. Okay, so here, what I want you to pick up is that there are 3 groups of 3. To get that 9, it's actually just 3 groups of 3. But I don't want you to memorize that it's always timesing itself. It's actually just how many options do you have per the options before. So that's why if you actually drew this out and you drew 3 options here, you would have done 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3. But you see, if you did this, this takes a long time. But you should be able to pick up a pattern again. For every group, every option, you have 3. And then for every option of this, you have 3. So it's 3 times 3 options times 3 options gives you the total number of options. Now, for some of us, that was not intuitive. Even as I'm not filling out the tables right now, some of you actually need to see the entire thing. And that's where the difference is between all of us. How quick can you see the logic? Okay, because for me, I'm seeing 3 groups of that option. And then this one has 3 groups for this option. So that means it's 3 by 3 by 3. So 3 times 3 groups, and then times 3 groups. That means in total, I should have a total of how many options? 27. In a logical sense, this is 27. Or you could do it like I said, if you did it this way. If you listed it all out, if you wrote out 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 3, 1, 1, 3, 2, 1, 3, 3, and listed it all out, yeah, you will get 27. And some of you would have done it through this way, intuitively. Okay, I'm just showing you a diagram to help you visualize what's happening. So once you know the total, that's how you can find the probability, because you need to know what's the total sample space. You need to know how many options there are available. So without figuring out this bit, you can't figure out the probability. Okay, so here we go. You can grab this one. Here we go. So that 27 is key. Now, just to test your understanding, because some of you are still sort of like, I'm pretty sure for the first time, not all students will pick up on that pattern there. That's the trick. I'm going to give you one that I want you to think about. Let's say this. In the morning, let's say that in my drawer, I have 3 pairs of socks, two pairs of jeans, and 6 t-shirts. So I have a lot of options to choose from, right? Let's think about it logically. What's my total number of options if in the morning I have to pick a pair of socks, a pair of jeans, and a t-shirt? What are all of my possible options here? So if you think about it, first one is I can have 1 sock, 2 sock, or 3 socks. I don't know which one I would have chosen. After I pick a sock, I have to pick a pair of jeans. So it could be gene 1 or gene 2. I'll call it AB. Gene A or gene B. After I've chosen a jeans, I need to pick a t-shirt. So shirt, it could be, I've used letters and numbers now. Let's go capital A, capital B, capital C, capital D, capital E, capital F. Yeah, so there's 2 jeans that I can choose from, 3 socks that I can choose from, and 6 t-shirts that I can choose from. Now my question is, what's the total number of options? Because if you want to work out the probability, you need to be able to figure out how many options I have in total. Now, using what I just taught you intuitively, now you can either draw it all out and figure it out, but I'm not going to draw it. I'm looking at it and I can already tell you how many total options I actually have. Anyone know? What's my total options? 36. Hands up if you had 36 in your head. Okay, there's a few. And that's what I meant. That's the challenge that I want you to pick up here. I had 3 options for the first one. The second one, I only have 2. That means it's 2 for this group, 2 for that group, 2 for this group. So it's 2 times 3. So already, 2 times 3 gives me 6 options. See that logic? 2 for this group, so that's 2. Plus another 2, plus another 2. So that's just like 2 times 3, isn't it? So 2 times 3 gives me 6. And then same thing for this one. I've got 6 options here, but then I had 6 options here. So 6 for every 6. 6 times 6 is 36. So I know it's out of 36. And then you can answer the questions. Get me? So what I'm trying to teach you there is to help those. When I asked you how many of you had 36 in your head, see, that's what I'm trying to say. There's a group on the top end who were able to understand what I'm saying. There's the middle group who would have guessed it and did, 1 sock, 1 jean, 1 t-shirt, and they'll list it all out. And eventually you get it if you're tenacious or resilient. And then there's a group who would have gave up, who would have done 1A and then saw the numbers and go, yeah, I give up. I'm not going to list it all out. So I'm trying to give you a tool, a visual aid, to allow you to solve those kind of problems. Make sense? Sully?
If it was, for example, like there were 4 sections, would it be the first 2 sections tied together and then the second 2 sections tied together and then those 2 times each other?
Well, usually they're timesing all together, as long as you're timesing them all together, because it's a group of, it's groups of groups. Yeah. All right. So that's just the intro. Okay. So the answer is 1 out of 27. But like I said, there are 3 groups of students that I see. Let's do an example so that you get a feel of what exercise 3I is about. Okay. So here we go. If a coin is tossed 3 times, so again, it's not the first time, that's 8G, most students pick up. It's when you start doing it like 3 times, 4 times, or 5 times. Here we go, write this down, Ashwin. Draw a tree diagram. So first flip. So do the first flip, what are my options? If I flipped a coin, how many options can I get? 2, very good. I can get either H or tails. That's my first go. So how many options do you have there? 2, very good. So that one's easy. Then if I flipped it 2 times now. So the second time, so I could have got a H on the first go. Second time could have been again, H. So I could have got HH. But I could also have had HT. But let's say I didn't get a H on the first go. I might have got tails on the first go. Then it would have been TH, TT. Now, when I write it all out, it's pretty clear that there's 1, 2, 3, 4 possible options that you can get. But in a logical sense, I'm trying to get you to picture what's happening. It's 2 options for this group, 2 options for this group. So it ends up being 2 times 2 because there's 2 here. So 2 groups for every option you have here. So 2 times 2. Yeah, so this is 2 times 2. That's how you get 4 options if I flipped it twice. So if I flipped it 3 times then without drawing the diagram, without drawing it entirely, how many total options should I get? How many? I don't want a lot. I want you to tell me. What's the number? 8. And again, it's because there's 4 options here, but for every option, you're going to get another 2. So 2 for that group, 2 for that group, 2 for this group, 2 for that group. That's 4 times. So 2 times 4 gives you 8. That's how I know without actually writing it all out. I know there are 8. But like I said, that middle group of students will normally write out H, 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 T, H, 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 T, H. And then they might go T, H, H. Okay, so they have a methodical way of writing it out, and they would list it all out, and it's okay. But if I give you a problem where there's like 12 options for the first one, 16 options for the second, and then 2 options for the last, you would have given up ages ago. And that's what I'm trying to give you. I'm trying to give you a mathematical way to be efficient instead of listing this out. It works up until it doesn't. Yeah? All right, so we know there's a total of 8. We've got our sample space. Great, let's answer the first question. What's the chances of getting 3 tails? So I'm looking for probability, tails on the first go, tails on the second, tails on the third. You told me there are 8 options in total, so it must be out of 8. How many options are there that you can get tails, tails, tails?
1 out of 64.
1 out of 8.
There's only 8 options there. So hence it's 1 out of 8. So
Bloody
you flipped it 3 times, not 4 times. Yeah? But even if it's...
64 options. 4 times 2 times 4 times 8.
2 times 4 times 8.
No. This is 2 options for every group here. So 2 for that, 2 for this, 2 for that, 2 for that. So 2 times 4. 2 times 4 gives you 8. Okay? All right, so this one is a bit easier. What about the last one? Now, I did this with the other class, and it was very interesting. Only one student figured out a shorter way of doing this one. The question says, find the probability of getting at least 1 tails. Okay, so I'm going to draw the diagram a bit clearer so you can see, and see how many of you can figure out a quicker way to do it. So you could have got H tails for this one, H tails for that one. So this is my 8 options. 1, 2, 3, 4, 5, 6, 7, 8. Right? Tails, tails, tails. There's only 1 there. So hence why we know it's 1 out of 8. My question, this one is, what's the chances of getting tails? Well, at least 1. So it's 1 or more. So you can have more than or equal to 1 tails. So what are the options? You can get tails, 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 H, tails, H, H, and then you can get H, T, H. How many total options are there? But only one student figured out the quicker way. Elizabeth.
You can only one thing without a tails, because that would be H, H, H. So basically it's the opposite of that, which means it would be about 7 out of 8.
Yeah, very good. Yeah. Now, some of you might not have picked up on that sort of logical part there, but think about it. Let's look at the diagram. Anywhere that has a T is acceptable. This one has a T. So any branch here has a T because you got a T there already, because we said at least 1 T, right? So as soon as you got 1 T, all of this is accepted. So there's at least 4 there already. But then you can keep counting and you say, well, there's a T there. But really, the one that I didn't highlight is this one. H, 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 which is what Elizabeth is saying. Why are you looking for just 1 T and more when it's actually easier to look for the opposite? Because the opposite has no T's. You said at least 1 T. So if you went for the opposite, there's only 1 out of 8 that has no T's. So that means, where's the rest? The rest is 7 out of 8 all has T's. That's the logic. Make sense? So if you said no T's, there was 1 out of 8. But then if you want at least 1 T, well, then it must be the leftover. If there's 1 out of 8 that has no T's, then there must be 7 out of 8 that has a T at least. So that's a quicker way of doing it. Otherwise, you could do what I just did here. You can count all of them, which is what most students do. By the time you get to year 11 and 12, the problems aren't like this easy to count. Using that logic that we just had is one of the key things to answer the year 12 type questions. Yeah? So the answer for this bit, yes, it's still out of 8. And you can count them all, or you can do the opposite of getting no T's. And we know that's 7 out of 8. Okay, so that's another way of doing it. Right? Technically, there's a proper formula for it where they say take the total, 100%, minus what you don't want. And remember, I taught you the word complement. That's what they learn at year 11 and 12. So technically, you guys learn it in year 9 and 10. But this is what the formula is. It's probability of A complement will give you, probability of, A complement. Yeah. That's one of the formulas, but I don't want to confuse you with that. So, there we go. That's it for today. That is your session. There is 9 minutes left. Remember, on Thursday, you have your session. Y8D Remember the quiz next week, okay, before your mastery learning task is submitted. Okay, it's going to go to your semester report. So make sure to double check it, answer it, update it, and I'm going to stop the video.